Good morning. My name is Kamil Stanek. I'm from the group of Architecture and the Environment, and I will present you a project, or actually it was a contractual research dealing with moisture and biodegradation risks in a crawl space of kindergarten building, which is timber-based. You can see the building on the pictures during the construction phase on the left, and after completion viewed from the south. The aim of the project was to reveal the causes of moisture and microbiological damage to the substructure of the building and propose technical measures for their permanent removal. What was the damage? The perhaps most obvious and noticeable was winter condensation and consequent mold growth on wooden sheeting of the north facade. But no less dangerous was spring and summer condensation, and again mold growth in the crawl space itself. Here we can notice that the crawl space, that means the space beneath the floor of the building, was only 0.27 meters high. It's quite important, so it was not really crawl space you can crawl in. What was the causes? What were the causes? At first, winter condensation. Here it's important to mention the ventilation regime of the crawl space. It was ventilated from south to north, and in winter it was due to the combined effect of wind and thermal buoyancy. And we can imagine that when the cold winter air entered the crawl space at the south and was passing through the crawl space, it was heated and it was also humidified, dominantly from the moist ground, which is almost infinite moisture source. And when such a humid and warm air entered the connected north facade, it was immediately cooled down and the condensation occurred. It was what the result we could see on the previous slide. The causes of spring and summer condensation. Here the situation was a bit different. After a cold period of the year, the entry area of the crawl space was quite cold, and we can imagine warm and humid April outdoor air entering this area, and again it quickly cooled down and the condensation occurred. All these phenomena were not very clear at the beginning of the project, and if in fact we needed advanced numerical simulations to describe them into detail. Some results you can see here, and on this picture is a vertical section with temperature field describing especially the cold entry area of the crawl space, approximately 1/3 of its whole length, which is 36 meters, while the rest is quite stable in respect to temperatures between 8 and 11 degrees approximately. And very similar temperatures can be observed in the crawl space in July, except the difference in the entry area. Here, this is a picture of humidity regime of the crawl space. This axis shows the distance from south, and this axis shows days of year, and the red zones are the condensation times and length. Most of them are concentrated during spring and summer. Sorry. So the temperatures in the crawl space in general are quite stable, only a few degrees above the average of the outdoor air, and the crawl space is moistened from two sources. First is the ground moisture, as we already mentioned, and the second is the outdoor air, especially in spring and summer. Well, what was the solution to all these problems? At first, it was necessary to make the crawl space accessible. Therefore, the ground below the floor had to be lowered. Some half-meter of soil had to be excavated. Then the vapor-tight foil was installed on the ground surface to prevent moisture evaporation from this source. Thermal insulation was placed on the substructures to prevent local thermal bridges, and in addition, peripheral drainage was done. But it was not all. Also, the north facade was separated from the crawl space, and the whole ventilation regime was changed. Ventilation chimneys with shutters were installed at the south facade, and the direction of ventilation was like this. Temperature and humidity sensors were installed in the crawl space and also in the outdoor environment, and connected to evaluation unit. And all this together we can call as a automatic adaptive ventilation. It's still a natural ventilation, but it is in operation only when the conditions are favorable. That means when the outdoor air cannot moisten or humidify the space below the floor. And here two pictures from the works. Here on the left you can see the excavation of the soil below the floor, and on the right picture the final appearance of the crawl space. The graph here with temperature and relative humidity courses are clear evidence that the solutions or the measures suggested work very well. The graphs cover the period of several years, and we can see that the relative humidity does not exceed 90%, which is quite safe from the point of view of molds and also moisture stability of construction materials involved. And so I can conclude that that the crawl space is safe and the whole kindergarten now, and that the project was quite successful. Thank you for your attention, and